Hey everybody, this is Larry. This is day 18 of the May Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And today's problem is find duplicate file in system. Okay, so I hope you didn't Google this and find this video because I get some complaints about it sometimes. But okay, so you have file stuff. Try to find return all duplicate files. Okay, group of duplicate files, two files with the same content. Okay, so this is actually somewhat practical, I guess. Single directory has this format. This is just a parsing problem, so you just have to be careful. It seems to be annoying, to be honest. Yeah, you could talk about your real system, and actually, this is very practical. I've built stuff like this before in Python, actually, to kind of just actually find duplicate files in system because I just I had image files that were what you call it, that I had in different directories, and I would just want to find the dupes and then remove them and so forth. And actually, I did them with depth first search. So yeah, they're one of the few times, maybe not that few, but when it comes up, it comes up. So okay. So file name, content, and so forth. Let's just actually paste this here so I could kind of see. So I can see. And then now it's just 4. It's a weird format for sure. And you may return the answer in any order. Okay. And it's just the file name. Okay, so I don't have to worry about the content. Okay, so that means that okay. For directory in paths, and then now yeah, okay. And then now for each directory, it's a little bit awkward obviously, but we split it by the space. And then we have the path, and then files maybe. Is that how to do it? I feel like there's a cleaner way to like, how do I do? Does this work? Or am I thinking of another language? Or will that just give me an error? Okay, so that does work. I have too many languages in my head sometimes, so I don't remember, and I have to check like an old man that I am. Okay, and then now for each file, we just put it in a hash table. And actually, when I was doing it live in real life, what I did was I actually hashed not on the file content, at least not initially, because the file content could be really big, right? And you know, like for example, if you are doing images files or video files, even, you know, that it can potentially be like megs or gigs and so forth. So I actually hashed the inode information stuff there, for example, just so that I can, you know, if that matches, then I do a more intense file hash. Maybe you even just hash the first, I don't know, the first like 1 kilobyte or something like that, and then do a second one before you actually, because the most expensive stuff is going to be reading the entire file content, especially if you're going to do this in real life, and just, you know, this guy always going to kill you. I mean, I know that there's some, like, you know, optimization with respect to the different cache layers, and you could talk about that during interviews, but I'm just gonna hand wave that part for now. Anyway, so now we have a lookup, let's just say, of the file contents, and yeah, put it in. I forget how to do this in Python. In Java, for example, VB2 hash code. I guess in this case, I'm just gonna put it in the hash table and let them decide. So that's fine. But yeah. So for file in files, you know, we have this format. So we'll just split on the left parens, I suppose. Yeah, wait. Just want to see that. Okay, yeah. Name content is equal to and we'll just oops, we'll just remove the last paren, the close paren. This is obviously very hacky, but this is also in real life really weird, or like you don't get the format like this anyway, is what I mean. And then now we just do lookup, like lookup content is you go append name, and I guess actually we should use default take up a list just so that's slightly easier. Different paths, right? Okay, yeah. Oh, and in that, actually I messed up a little bit because I think they could be in different directories. So okay, so different directories have, that makes sense. Different directories might have the same files, so I do, I move the lookup ahead, and actually instead of name, I actually want the path as well, right? And of course, in real life, I would also recommend using libraries for the path and names. It's very easy to mess up, and it's very easy to I think there's like a path lib in Python, for example, but you should definitely use it so that you get an OS compatible one that does it for you and does all the little weird things for you. In real life, a lot of use libraries because you're lazy like I am, and also because they handle all the edge cases. Well, not all the time, but you can trust it to, for the most part, to handle a lot of edge cases and weird cases and so forth. So anyway, so yeah, and then now we can just do yeah, let's see. I'm just gonna write it out, but wait, what is the format again? I'm just looking at the format. Okay. So for just keys in lookup dot. I guess lookup the values is fine actually. Rouse from lookup in files if length of rouse is equal greater than 1, meaning that there are at least 2 or more, then we append rouse. And you can of course write this in one line of code, but that's why I was thinking if I should do it, but I was like, for the stream maybe I should be a little bit explicit. How is this given as an input, just like this? Oh, okay. I could just copy this and paste that. It's never clear in Leetcode what the format is. Do I still print stuff? No. Okay. Now I'm just double checking whether I just have them in a different order. It seems like I just have them in a different order. So let's give it a submit. Also, are these two? No, they're different. Okay. Ooh, wait. Oh no, it's good. Okay, let's just give it a submit. I think it looks okay by eyeball, but that's why you let the computer do stuff for you, so you don't have to eyeball it or verify it for you. Yeah, so that looks good. So what is the complexity, right? For each file, we do 1 hash, so it's gonna be linear in it's gonna be linear in time, because for every character for every byte bit in the input, including the file contents, you're only going to read it once and use it to hash and so forth, or over one time. And in terms of space, we also, at least the way that we did it, because we're lazy with the content, is also linear, because we put everything in this lookup table, and then we also created it. Well, I guess this is just a reference, but still, yeah. That's all I have for this problem. Let me know what you think. Yeah, I'll see you out tomorrow. Yeah, let's see. Yeah, I think that's what I have for this problem. But you can see that in real life this happens, and like I have scripts like this that do more or less the same idea. But yeah. I mean I think we talked about some of this even without me reading this. But yeah, in a real file system, you just do depth of search. Essentially, they did the search for you and give you the traversal of the thing, kind of. The file's content's very large. As we said, we'll probably hash like the inode or something like that, or just yeah. And we could read the file by 1K each time. How would you modify your solutions? Actually, I actually mentioned this a little bit, even with this constant without mentioning it. But yeah. Or about reading it. Maybe it's a subconscious. I don't know if I noticed it. What's the time complexity? The most time consuming and memory consuming is also always going to be I/O in these cases, both to and from disk and even from memory. Like I said, you could just take a sub chunk of it, text or assemble it or whatever. And how do you make sure the duplicate files are not false positive? You just do one more pass at the end. I mean, you could also double hash it or something like that. It's just very standard hashing collusion answers. So I'm not going to go over that deeply. But yeah, that's all I have for today. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. And also, yeah, stay good, stay healthy, and to good mental health. I will see you later. Bye bye.